So this is another example that's not really a problem. It's just kind of telling us something. But let's look at what it has to tell us. So we're talking about this function, f of x equals the absolute value of x minus 2. So you see I sketched it for you there. And then they're talking about the one-sided limits. So they're like right here at 2. They want you to notice that the derivative on the left side. What's the derivative on the left side of 2? Of this line right here. We'll see how it's just a line. And if you know absolute value, that should be -1. That's what that tells us right there. You see, they actually calculated it, but you can just look at it. It's a line. That slope is -1. But then what happens at 2? At 2, it turns around. And look at that slope over here, 1. And so what they're getting at here is that since there's not a smooth change, there's no derivative here at the corner. So at x equals 2, there is no derivative. And honestly, the best way that I have to show that, I used to do this on the edge of my desks at school all the time, but the NumWorks calculator works for it really well too. Because the idea is, let's see how well this is going to look. If you get right here, notice that when you tilt, say the pencil is the tangent line and the calculator is the graph, notice that when you change the slope of the tangent line, the point of contact changes too. In other words, to say at any single point of contact, there's only one slope of the tangent line. And if you change the slope of the tangent line, you go to a different point of contact. And so that's differentiable. At every point, there's only one derivative. That's versus these sharp corners here. If we're right on this sharp corner, then now see how if we change the slope of the tangent line, it actually just stays at the same point. It doesn't move. The point of contact can remain the same and still have different slopes. And so that's why there's no derivative, because there's no singular output. You can have as many slopes as you want here on this tight corner. And that's exactly what's happening with this graph. You can draw a tangent line like there. And see, it's still sort of tangent. Is what it's tangent. Tangent's just like crossing through one point. So it's like you can draw a line here that crosses through one point. Or crosses, all these lines are crossing through like the same point. They just all have different slopes. And so that means it's not differentiable because there's not a singular slope. And see how that's different than if there was a curve. And we talked about like this point right here. There's only one tangent line. You can't draw another line that goes through that point that's tangent. That goes through that singular point because it's a curved. But on a pointed surface, you can. So the gist of this example is that it's not differentiable if there's what you call a cusp. A cusp just means a sharp corner. So if there's a sharp corner on the graph, it's not differentiable there. That's all that's saying.